Okay, so now I want to prove the following theorem, or one part of the theorem. So there's going to be two parts. I'm going to state and talk about the first part and prove it in the next video. So I want to prove that if we have some sequence and the limit of the AK is equal to L, and I'm just going to assume that that L is a finite number, so its absolute value is less than infinity. There's a theorem of what we could also prove something when L is equal to plus or minus infinity. I'm going to let you read the book for that part. But the limit of AK is equal to L. Then the statement is going to be that the Liminf, which we know exists, is equal to the Limsp, which we know exists because all Liminf and all Limsps always exist for any sequence, and they're actually both equal to L. Okay, the idea, let me go back to this paper. Let me say this one more time. If you have some sequence and its limit is equal to L, and L is a finite number, L is a real number, then the Liminf and the Limsp are equal to each other, and they're equal to that L. So let's go back to this picture that I drew. So notice what's happening. If the AK sequence is converging, since the Limsp is the least upper bound, the AK sequence converging kind of is going to pull that down, because it's not just any upper bound, it's the least upper bound. So if the AKs are approaching L, then the least upper bound is also going to be approaching L intuitively. And similarly, the least upper bound, the greatest lower bound, the sequence is sort of pulling that up because it's the greatest lower bound. So if the AKs are increasing, then it's going to be pulling it up that way. Okay, and that's even this pulling it down and pushing it, or the AK sequence pulling the sup sequence down and lifting the inf sequence up. That's kind of even gonna bear out in the proof a little bit. But let me just explain how I'm gonna think through this. For large K, we know that AK is going to be approximately equal to L. Now, what do we mean by that? We mean precisely that I can take K large enough so that AK minus L is going to be less than epsilon for K after a certain point. So in other words, if I just look at the tail end of the sequence, AK is going to be all of the AKs are going to be very, very close to L. Remember, that's what it means to converge to L, is that I can make AK as close to L as I want by making the index sufficiently large. So I know this is going to be true for all K greater than some n. All right, now what does this mean? If I look at the tail end of the set, what this means is all of the AKs past a certain point are approximately equal to L. So they're all approximately equal to L. They're all very close to L. This means the inf has to be close to L, and the supremum has to be close to L. In fact, if instead of inf and sup, we could say min and max, if I know that all the AKs are very, very close to each other, after a certain point, all the AKs are very, very close to L, then the minimum has to be very, very close to L, and the maximum has to be very, very close to L. Indeed, since everything past a certain index is going to be close to epsilon, this means that the minimum can be at most epsilon away from L, and the maximum can be at most epsilon away from L. And so this is going to be the idea of the proof that we use in the next video, that as the sequence is going along, the mins and maxes have to be pulled closer to the limit. If the AKs are close to L, the minimum has to be close to L, and the maximum has to be close to L. Now, of course, there's no guarantee that there's a minimum or a maximum, but since the infimum is the greatest lower bound and the supremum is the least upper bound, something similar is going to be true. That if all of the AKs are within epsilon of L, then the infimum can't be more than epsilon from L, otherwise we would have a different lower bound. And we'll make all of this precise. So given what I just said, before you watch the next video, where I'm going to give a proof of this, before you watch the next video, try to come up, along with what we did in class, along with the video that I'm making now, see if you can put together the pieces for the proof.